Hi, welcome to my channel. In this video, we want to solve the following problem. Given triangle ABC, let D be a point on BC such that angle DAB equals theta and angle CAD equals 2 theta. Given that AD equals CD equals y units and BD equals AC equals 1 unit, the goal is to find the value of y. And now for the solution. First, let E be a point on CD such that angle EAD equals theta and angle CAE equals theta. Next, let's denote the length of AB as A, the length of AE as B, and the length of DE as Z. Then the length of CE equals y minus Z. Following this, consider triangle ADC and the line AE. Let's apply the angle bisector theorem to triangle ADC. Given a triangle with these dimensions, the theorem tells us that A over B equals P over Q. Applying the angle bisector theorem to triangle ADC, we obtain y over 1 equals z over y minus z. After cross multiplying and then rearranging, we obtain y squared equals z times y plus 1, or z equals y squared over y plus 1. Next, let's apply Stewart's theorem to triangle ADC. Given a triangle with these dimensions, Stewart's theorem tells us that m squared equals AB minus PQ. By Stewart's theorem in triangle ADC, we obtain b squared equals y times 1 minus z times y minus z. Substituting z equals y squared over y plus 1 gives us b squared equals y minus y squared over y plus 1 times y minus y squared over y plus 1, which simplifies to b squared equals y minus y cubed over y plus 1 whole square. Next, consider triangle ABE and the line AD. Applying the angle bisector theorem to triangle ABE, we obtain A over B equals 1 over Z, or B equals AZ. Substituting Z equals y squared over y plus 1 gives us B equals AY squared over y plus 1. Next, applying Stewart's theorem gives us y squared equals AB minus Z times 1. Using b equals ay squared over y plus 1 and z equals y squared over y plus 1, we obtain y squared equals a squared y squared over y plus 1 minus y squared over y plus 1. Y squared cancels out, giving us 1 equals a squared over y plus 1 minus 1 over y plus 1, which simplifies to a squared equals y plus 2. Substituting b equals ay squared over y plus 1 into b squared equals y minus y cubed over y plus 1 whole square, we obtain a squared y to the power 4 over y plus 1 whole square equals y minus y cubed over y plus 1 whole square. Substituting a squared equals y plus 2 then gives us y to the power 4 times y plus 2 over y plus 1 whole square equals y minus y cubed over y plus 1 whole square. Next, we multiply both sides by y plus 1 whole square to obtain y to the power 5 plus 2y to the power 4 equals y times y plus 1 whole square minus y cubed. Expanding the brackets gives us y to the power 5 plus 2y to the power 4 equals y cubed plus 2y squared plus y minus y cubed. Y cubed cancels out, and we are left with y to the power 5 plus 2y to the power 4 minus 2y squared minus y equals 0. Since y is non-zero, let's divide both sides by y to obtain y to the power 4 plus 2y cubed minus 2y minus 1 equals 0. To solve this equation, we write 2y cubed as minus y cubed plus 3y cubed, and then subtract and add 3y squared. Next, we write minus 2y as minus 3y plus y. We then factor out y cubed from these terms to obtain y cubed times y minus 1. Factor out 3y squared from these terms to obtain 3y squared times y minus 1. And factor out 3y from these terms to obtain 3y times y minus 1. The expression thus factors as y minus 1 times y cubed plus 3y squared plus 3y plus 1. We recognize the second factor as y plus 1 cubed. Therefore, we have y equals 1 or y equals minus 1. Since y is positive, we have y equals 1, which is the solution to our problem. As an exercise, try to solve this problem and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.